Alright, Antioch Bears, the fourth and final installment of solving quadratic functions, this time with the quadratic formula. This guy is a fail-safe. He can solve any quadratic function you may encounter. It will also be on your formula page when you take the end of the year test. It's one of the formulas they've included on there. So I'm looking at a quadratic function that is a trinomial. There's a leading coefficient. Really don't want to go about factoring it or anything else. I'm going to go straight to the quadratic formula. There are places for the letters we're already familiar with, A, B, and C. Well, as long as you've got it equal to 0, or if y is by itself, A is the number that's in front of x squared, B is the number that's in front of x, C is the number without x. So all I have to do is make sure I plug these numbers, -3, 5, and 6, into the right spots here. My calculator can do most of the heavy lifting for me even, and I can come up with my solutions. So I'm going to rewrite the formula without the letters and just a set of parentheses for something to plug into. According to the formula, first spot is B. B in this situation is 5. Then B squared, so 5 squared, minus 4 times A and then C. A and then C. A is -3 and C is a +6. All that gets divided by 2 times A. A is -3. On the outside I end up with -5 plus and minus the square root of 5 squared is 25. -4 times -3 times +6. That's something I could type all in my calculator at once if I wanted to. It gives me a +72. All that gets divided by 2 times -3, which is -6. Now I have -5 plus minus the square root of, and I'm going to combine the two numbers, 25 and 72. And I get 97. Now I need to find the square root of 97. It's about 9.8. So now I'm going to rewrite this as -5, and I'm going to split up my two signs, plus 9.8, which was the square root of 97, divided by -6, and rewriting it again, this time using the minus sign, -5 minus 9.8, divided by -6. -5 plus 9.8 is 4.8, divided by -6, I get -0.8. It's one of my answers. In the other one, I've got -5 minus 9.8 divided by -6. -5 minus 9.8 is -14.8, divided by -6 is about +2.5. I'll show you another example where the B value is missing. We see an A value, well we don't see it, but we know what it is, it's 1. We see the C value of -4, but B is missing. If you're using the quadratic formula and any piece is missing, just go ahead and plug in the number 0 for that. So once again, the quadratic formula, -b plus or minus square root of b squared minus 4ac divided by 2a. I'm going to put parentheses in the spots there should be our variables. So outside here goes in b. B is missing, so b is 0. Plus minus the square root of b squared, once again 0 squared, minus 4 times a times c. A is 1, c is -4. All that gets divided by 2 times a. Once again, a is a +1. Now there's really no such thing as a -0, nor is there such thing as a +0. So just call that 0 or leave it off altogether because it's really not necessary. I'll go ahead and write it. 0 squared is 0. And then -4 times 1 is -4 times -4 again would give me a +16. All that gets divided by 2 times 1, which is 2. 0 plus and minus the square root of 16 over 2. So I get 0 plus the square root of 16 is 4 divided by 2. And 0 minus 4 divided by 2. 0 plus 4 is 4. 4 divided by 2 gives me a +2. 0 minus 4 is -4. -4 divided by 2 gives me a -2. Now I got my answers through the quadratic formula, but on the test you guys are going to be given a section where you're told you can solve them any way you can. And I hope you recognize that if you're missing the b value, The quickest and easiest way to solve this is the first way I showed you, which was with square roots. If I rewrite this over here, this was a lot easier to solve than using this. I would just have to add 4 to both sides. I get x squared equals 4, then take the square root. And remember that when you take the square root in both sides of an equation, it could be positive or negative, and square root of 4 is 2. Same answers I got down here. But part of the reason we teach all 4 methods is so that when you start doing a bunch of these, you can look at them and see what would be the best way to attack it. And that covers solving quadratic functions. Remember that it's all about where your parabola is going to cross the x-axis. This one, for example, would have crossed at -2 and +2. Have a good weekend, Bears.